The goal of this video is to show how to adjust our annual compounding formula for other periods of compounding, such as semi-annually, which means twice a year, quarterly, 4 times a year, monthly, each month, so 12 times a year, and so on. Our standard formula, as shown above, has a very adaptable format. For the annual one, we would be doing the following. A equals 5,000 times 1.08, because 8% written as a decimal is 0.08, and when we add it to 1 we get 1.08, and we would raise that to the 10th power because we're going to compound it 10 times in those 10 years. However, we can simply adapt this formula for shorter compounding periods if we wish, where we think of the variables as labeled above, where x, instead of the 8% that you would get each year, is chopped into the number of pieces that the year is broken up into. So if you compound twice a year, you would chop it into 2 pieces and only get 4% instead of 8%, but you would get 4% every 6 months, and you would also have twice as many compounding periods. So you wind up getting interest on your interest a little bit sooner. So this problem right here, the one that we've originally started with, would finish with 5,000 times approximately 2.15892, etc., if you continue out with the decimals, raised to the 10th power. I'm going to erase that last little part. So it's just, I've already raised 1.08 to the 10th, and it's 2.15892,499, etc. And when you multiply that by 5,000, you get approximately $10,794.62, approximately. Now here's a second problem, slightly adjusted from the original problem. What this means is we're going to look for what our total amount is. If we start with 5,000, but now instead of getting 8% once a year, we're going to increase our amount by 4%, or half of 8%, and do it twice a year. So every 6 months, we go up 4%, which means that our multiplier is 1.04. So we get 104% of our original starting amount of 5,000 after each compounding period. Now, instead of 10 compounding periods, in 10 years, we should get 10 times 2 compounding periods, or 20 compounding periods. So we're going to do 1.04 raised to the 20th instead of 1.08 raised to the 10th. Now this is fairly close to the original, but because we start getting interest on our interest a little sooner, this amount right here is going to give us a slightly higher multiplier than we had before. So 1.04 raised to the 20th is approximately 2.191123, etc. And when we multiply this by 5,000, we now get a slightly higher amount than we got on the previous page. And that is approximately $10,955.62. Let's look at how to adjust for compounding quarterly. Here's the example. So again, it's going to be the amount we'll have at the end is 5,000 times. Now would be a good time to pause the video, try to do this for yourself, and then look to see what I'm doing. So if you're back now, instead of getting 8% once a year, we're going to get 1/4 of 8% 4 times a year. 1/4 of 8% could be written as 1 plus 0.08 divided by 4. That gets you 1/4 of 8%. We'll sort that out in just a moment. And of course, it's 2%. So what we're going to get is 5,000 times 1 0.02, so it's going to go up 2% each quarter instead of 8% a year, or in our previous example of semi-annually, 4% every 6 months. And the question now is to ask yourself how many times we're going to compound this. In other words, how many quarters are there in 10 years? Well, of course, there's 10 times 4, or 40 of them. So 1.02 raised to the 40th is approximately 2.2080396, etc., as I've shown. And when you multiply that times 5,000, you now get the answer of approximately $11,040 and rounded to 20 cents. So once again, we've shown the adjustment. Remember, this number is now 4 times bigger than the original annual rate. And this percent, which gives us that as a decimal, is now 4 times smaller because we're doing it for only 1/4 of a year. Ultimately, we can continue this process, so let's show on the next slide 10 years compounded monthly. Now this is a little more awkward because the numbers don't work out as nicely. So we're going to say it's 5,000 times 1 plus, now 0.08 over 12, because it's broken into 12 chunks, and 10 years times 12 times a year compounding periods. So there are 120 compounding periods, and we now have in this section right here a decimal that we have to keep good track of in our equation, in our formula. And 0.08 divided by 12 is actually 0.0066 repeating, so our decimal is going to be 1.0066 repeating, and we're going to raise this to the 120th power. Now you should simply, using your calculator, keep this as accurate as possible by taking this number and adding it to 1 so that you get this nice multiplier here, and then raise that to the 120th power. That keeps it accurate. So that gives us approximately 2.219640, etc., which when we multiply by 5,000 gets us approximately $11,098.20. So once again, we've shown the adjustment for each of these compounding period times, and remember that the general formula for this is to think, what is the multiplier for one compounding period by chopping the annual interest rate. And remember, anytime I tell you it's 8% for 10 years compounded monthly, 8% is nominally an annual rate. And so it is the rate you would get if you were doing it annually in a compounding period. But each time you cut the compounding periods into smaller pieces, you must, of course, chop the 8% into smaller pieces. You don't get, of course, 8% each month as an increase. That would be an exorbitant rate, which you would love to get if you were investing, I guess. But the basic principle here is that the 8% gets chopped into 12 pieces because it's compounded monthly here. I hope this is made as clear as possible how to adjust for different compounding periods.